Hello all, I hope you all are good. Today we are going to discuss how to find dimension of a vector space, which is one of the important topic of linear algebra for IIT JAM, GATE, CSI NET and other exams with similar syllabus. There are few steps to find dimension of a vector space. Step 1. Select most general form of vector. Step 2. Express this vector. This vector means which we are selected in Step 1. In terms of the elements of the field of the vector space. Step 3. Count the number of unknowns which we are free to choose to define the general vector. Now we will consider some examples to understand these steps. Now example first is Cn over R. According to step first, we will select vector from Cn. Any vector belongs to Cn, Z belongs to Cn is of the type Z equals to Z1, Z2, Zn, where each Zi comes from complex number and I runs from 1 to n. Now according to step 2, we will express these vectors in terms of elements of field. Here field is real number, so we will express Z1, Z2, Zn in terms of real number. So Z1 can be written as A1 plus IB1, Z2 can be written as A2 plus IB2, An can be written as An, Zn can be written as An plus IBn, where each ai comma bi comes from real number. Here there is no condition, so we can count number of unknowns. Here number of unknowns are 2n, so dimension of Cn over R is 2n. Now field is complex number, so there is no need to express Z1, Z2, Zn in terms of real number. So count number of unknowns is n, so dimension of Cn over C is n. I hope you will understand this example. Now we will move to the third example. Third example is set of 3 cross 3 real symmetric matrices. So any vector belongs to V is of the type x equals to a11, a12, a13, a21, a22, a23, a31, a32, a33. Here condition is given aij equals to aji, so a11 remains a11, a12 remains a12, a13 remains a13. Now a21 can be written as a12, a22 remains a22, a23 remains a23. Now a31 can be written as a13, a32 can be written as a23 and a33 remains a33. Now count number of unknowns. Here number of unknowns are 6, so dimension of V is 6. Suppose aij comes from complex number and field is real number, so number of unknowns will become twice, so dimension of V is 2 into 6 equals to 12. Now we will move to example 4. Example 4 is n cross n real symmetric matrices and field is real number. So any vector belongs to V is of the type x equals to a11, a12, a13, so on a1n, a21. Now a21 can be written as a12, a22 remains a2, a23, so on a2n, a31 can be written as a13, a32 can be written as a23, a33 remains a33, so on a3n. Now so on it will be a1n, because an1 can be written as a1n, so on an2 can be written as a2n, so on an3 can be written as a3n, and ann remains ann. All comes from real number and field is real numbers. So we will count the number of unknowns. Here number of unknowns are n. Here number of unknowns are n minus 1. Here number of unknowns are n minus 2. Here number of unknowns is only one, ann, that is 1, because we already count a1 and a2n. So total number of unknowns is n minus 1, n minus 2 plus so on plus 1. So sum of n natural number is n n plus 1 upon 2. So we generalized set of n cross L symmetric matrices have dimension n plus 1 upon 2. So in previous example we can also get the answer by using the formula. Here n equals to 3. So dimension of V is 3 into 3 plus 1, 4 upon 2 equals to 6. Now we will move to next example. Next example is set of n cross n real skew symmetric matrices. So we will take any vector belongs to V. Any vector x belongs to V is of the type x equals to a11, but a11 by given condition equals to minus a11. So it is only possible when a11 equals to 0. Next a12, a13 a1n. Now a21 can be written as minus a12, a22 will become 0, same reason, a23 so on, a2n. A31 can be written as minus a13, a23 32 can be written as minus a23, a33 will become 0 so on, a3n an1 can be written as minus a1n an2 can be written as minus a2n a3n can be written as minus a3n so on, an will become 0. Now they are all real numbers and field is real number. Now we will count the number of unknown. Here number of unknowns are n minus 1 because 1 is 0, even 1 is 0, and here number of unknowns are n minus 2 because it repeats and other is 0. Number of unknowns are n minus 3, here number of unknowns are 0, and in previous one and number of unknown is 1. Now count the number of unknowns. Here number of unknowns is n minus 1 plus n minus 2 plus n minus 3 plus so on plus 1 up to n minus 1 times. So we know that sum of n natural number is n plus 1 upon 2. So sum of n minus 1 natural number will be n minus 1 plus 1 divided by 2. So it will become n minus 1 divided by 2. Now suppose aij comes from complex number and field is real number. So unknowns will become twice. So dimension of V will be 2 into n minus 1 upon 2 is n minus 1. Now we will move to the next question. Next question is given. V1 is given set of 10 cross 10 real matrices such that aij is 0 if I divides n. V2 is set of 10 cross 10 matrices such that aij equals to 0 if GCD of I comma n is 1. We have to find dimension of V1, dimension of V2, dimension of V1 intersection V2 and dimension of V1 plus V2. First we find dimension of V1. We know that 1 divides 10, 2 divides 10, 5 divides 10 and 10 divides 10. So first row, second row, fifth row and 10th row will become 0. So there are only 6 rows which are non-zero. So number of unknowns will be number of unknowns are 60. So dimension of V1 is 60. Similarly for V2, GCD of 1 comma 10 is 1, GCD of 3 comma 10 is 1, GCD of 7 comma 10 is 1 and GCD of 9 comma 10 is 1. So first row, third row, seventh row and ninth row will become 0. There are 6 non-zero rows. So number of unknowns are 60. So dimension of V2 is 60. Now we have to find dimension of V1 intersection V2. Now any vector belongs to V1 intersection V2 will satisfy both V1 and V2. So first, second, third, fifth, 7, 9 and 10th row will become 0. there are only 3 non-zero rows, so number of unknowns are 30. So dimension of V1 intersection V2 is 30. Now we know that dimension of V1 plus V2 is equals to dimension of V1 plus dimension of V2 plus minus dimension of V1 intersection V2. Now dimension of V1 is 60, dimension of V2 is 60 minus dimension of V1 intersection V2 is 30. So we have 120 minus 30 equals to 90. Now we will do some previous year questions. Let V be the vector space of all 2 cross 2 matrices over R. Consider the subspaces W1 and W2. If M equals to dimension of W1 intersection W2 and N equals to dimension of W1 plus W2, then the pair M comma N is. We have to find dimension of W1 intersection W2 and dimension of W1 plus W2. Now any vector belongs to W1 intersection W2 is of the type X equals to, suppose A1 1. Now according to W2, A12 will be minus A11 and according to W2, A21 will be minus A11. Now A22 remains A22. Here number of unknowns are 2, so dimension of W1 intersection W2 is 2. Now we know that dimension of W1 plus W2 equals to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Dimension of W1, here unknowns are 3, so dimension of W1 is 3. Here number of unknowns are 3, so dimension of W2 is 3 minus dimension of W1 intersection W2 is 2. So 6 minus 2 equals to 4. So correct option is 2, 4. I hope you will understand this question. Now we will move to the next question. Let V be the vector space of all 6 cross 6 real matrices over the field R. The dimension of the subspace of V consisting all symmetric matrices is. We know that dimension of n cross n real symmetric matrices is n plus 1 upon 2. Here n is 6, so 6 into 7 upon 2 is 3. 7 3s are 21. So correct option is 21. Now we will move to the next question. Let M5R denote the vector space consisting of all 5 cross 5 matrices with real entries over the real number field. Let W be the subset of M5R be the subspace of all skew symmetric matrices. Then dimension of W is. We know that dimension of n cross n real skew symmetric matrices is n minus 1 upon 2. Here n equals to 5. So 5 into 4 upon 2 is 2 and 5 into 2 equals to 10. So correct option is 10. Now we will move to the next question. Which of the following is a two-dimensional subspace of R cube over R? Option A 0, x, 0, x belongs to R. Here number of unknown is 1, so dimension is 1. So A cannot be true. Option C 0, x, 0, x belongs to R. Union 0, 0, y, y belongs to R. This is not a subspace because 0, 1, 0 and 0, 0, 1 belongs to B, but their addition 0, 1, 0 plus 0, 0, 1 equals to 0, 1, 1 does not belongs to B. So it is not subspace, so it cannot be true. Similarly, x, y, 0, xy belongs to R and x is not equals to y is also not subspace because 1, 2, 0 belongs to C and 2, 1, 0 belongs to C. Their addition is 1, 2, 0 plus 2, 1, 0 equals to 3, 3, 0, which does not belongs to C because x equals to y. So C cannot be true. Here 0, y, z, yz belongs to R. Here number of unknowns are 2, so dimension of D is 2. So option D is true. Now we will move to the next question. Let V be the real vector space of all polynomials in one real variable and with real coefficient have a degree at most 20. Define the subspaces W1 and W2. Then the dimension of W1 intersection W2 is. So any polynomial belongs to V is of the type is of the type Px equals to A0 plus A1x plus A2x square plus so on A20 x की power 20. Now any polynomial belongs to W1 intersection W2 is of the type Px equals to A0 plus A1x plus A2x square plus so on A20 x की power 20 and P1 is 0, P1 by 2 is 0, P5 is 0, P7 is 0, P3 is 0 and P4 is 0 because P satisfy both W1 and W2. So we can find one unknown from this condition, 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 one unknown from this condition and one unknown from this condition. So we can find total 6 unknowns from these conditions. Here number of unknowns are 21. So total number of unknowns are 21 minus 6. So it is 15. So dimension of W1 intersection W2 is 15. So correct option is 15. Now we'll move to the next question. The dimension of the vector space V. Here V is the set of all skew symmetric matrices and elements of the matrices comes from complex number and field is real. We know that when elements come from real number and field is real, then dimension is n minus 1 upon 2. But here elements come from complex number and field is real, so it will become twice of n minus 1 upon 2. So correct option is n square minus n. So option C is correct. Now we'll move to the next question. Consider the subspace W Aij. Aij equals to 0 if I is even of all 10 cross 10 real matrices. Then dimension of W is. So 2 is even, 4 is even, 6 is even, 8 is even and 10 is even. So second, fourth, sixth, 8th and 10th row will become 0. There are only 5 non-zero rows. So number of unknowns are 50. So dimension of W is 50. So correct option is B. Now we will move to the next question. They are given let A is a 3 cross 3 matrices and V is the set of elements of R cube such that determinant of A is 0. Then dimension of V equals to. Now we will solve determinant of A. Determinant of A equals to 0, which implies 2z minus 3y minus 2z plus 3x plus 2y minus 2x equals to 0, which implies 2z 3x minus 2x x and minus 3y plus 2y minus y equals to 0, which implies x equals to y. So we have v equals to x comma y comma z belongs to R cube such that x equals to y, which implies v equals to x comma z belongs to R cube. Here number of unknowns are 2, so dimension of v is 2. So correct option is 2. Now we will move to the next question. The dimension of the vector space of all symmetric matrices A of order n cross n is greater than equals to 2 with real entries A11 equals to 0 and trace 0 is. So we know that dimension of real symmetric matrices is n plus 1 upon 2. Here a11 is 0, so one unknown is known, so we subtract minus 1. It is also given trace is 0, so a22 plus a33 plus dot dot dot, so on a n equals to 0. We can find one unknown from here, so minus 1 will also. So dimension will become n square plus n minus 4 upon 2. So correct option is A. Now we will move to the next question and last one. The dimension of the vector space of all symmetric matrices of order n cross n is greater than equals to 2 with real entities and trace equals to 0 is. We know that dimension of real symmetric matrices of order n cross n is n plus 1 divided by 2, but it is given that trace is 0. So a11 plus a22 plus a33 plus dot 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 a n equals to 0. We can find one unknown from here, so we subtract minus 1. So dimension become n square plus n upon 2 minus 1. So option C is correct. I hope you all understood the concept. Thank you very much for your precious time.